And here goes the last tutorial with this set of slides. Math, math, and more math. Let's go ahead and take a look at what we have. It's asking us for liters of carbon monoxide. So I'm trying to get to volume, and keep in mind that's of carbon monoxide, CO. It tells me that it's at 27 degrees Celsius, 0.247 ATM, and that we are burning 65.5 grams of carbon according to this equation. So once again, we've got a non-STP situation. And when you see that non-STP, what you need to understand is there's really two parts to it. Part one is looking in that they want the volume of carbon monoxide. If the pressure is 0.247 ATM, our temperature is 27 degrees Celsius, but remember we're going to add 273 to that value, and that's going to give us 300 Kelvin. And all we really need to complete that ideal gas law is the number of moles. Because if we have the pressure, we have the number of moles, R is a constant, T is our temperature, we can solve for volume. The problem is that the mass value that's given to us is grams of carbon. And what we need that to be in is moles of carbon monoxide, because that's what we need up here. So let's go ahead and take that 65.5 grams of carbon, and we're going to turn that into moles of carbon monoxide. We're going to start by doing exactly what we did last unit, and we're going to drop down grams of carbon. And we know that 1 mole of carbon weighs 12 grams. And now let's go ahead and drop down moles of carbon, and this is where we've got to look up there to our coefficients. And in this situation, they cancel out very nice. Multiply straight across and then divide, and we end up with 5.46 moles of carbon monoxide. Now that we have that value, we can go ahead and use that ideal gas law. Pressure times volume equals nRT. And let's plug in what we have. The pressure we know is 0.247, and that's ATM. And remember, units here are very important for us because of that universal gas constant. The number of moles is 5.46. I'm writing the units below just so you can kind of keep track of where I'm coming up with these numbers. The next variable is R. R is your universal gas constant, and it is located on the periodic table that you were given at the beginning of the semester. You have two values. You have 8.31 and you have 0.0821. And if you look closely, we're going to use the 0.0821 because of the pressure units. If the pressure had been in kPa, kilopascals, we would have used 8.31. And then the last value that we need to plug in is the temperature, which is 300 Kelvin. And so now let's go through, multiply, and then divide. See what you get. 544 liters of carbon monoxide gas. Again, you're going to use a Stoich problem, and then you're going to use that ideal gas law to solve for that final answer.